Think about any little move you just made. Maybe you shifted in your chair or reached for your phone. You just did it, right? It just happened. But behind that one simple action is this incredible hidden world of calculation. Today we're going to pull back the curtain on your brain's two master movement managers, the systems that make every single thing you do possible.
Seriously, think about this for a second. Grabbing a coffee cup seems like the easiest thing in the world, but how do you not overshoot it? How do you grip it with just the right amount of force so you don't crush it, or worse, drop it? Why is that movement so incredibly smooth pretty much every single time?
Well, the reason it's not a total mess is because your brain is doing all this heavy lifting in the background. For every single action, it is selecting, suppressing, grading, predicting, and correcting all at once. And you're not even aware of it. This is the work of two brilliant specialized managers deep inside your brain. So how does the brain pull this off? Well, here's our roadmap. First, we're going to properly introduce our two managers. We'll start with the selector, the basal ganglia, and then we'll meet the predictor, the cerebellum. After that, we'll see how they talk to each other in this constant essential feedback loop. And finally, we'll take a look at what happens when this amazing system breaks down.
Okay, so to solve this incredibly complex problem of just moving around without flailing everywhere, the brain delegates. It's smart. It has two key structures that work together, the basal ganglia and the cerebellum. You really can think of them as a super efficient management team.
So here's the division of labor. The basal ganglia is what we'll call the selector. Its main job is to look at all the possible movements you could make and choose the right one for the job. It's the gatekeeper. At the same time, the cerebellum is the predictor. Think of it as the quality control expert, making sure that the move the selector picked is performed with perfect timing and accuracy.
All right, let's dive in with our selector. Now, the basal ganglia doesn't come up with the idea to move. That comes from higher up. But its role is arguably one of the most important, because it's like the bouncer at the club of motor action.
So the key thing to get here is that the basal ganglia is all about selection. Imagine your brain has a dozen different ways you could move your arm to grab that cup. The basal ganglia's job is to pick the one best plan for that goal and, just as important, to slam the door shut on all the other competing ideas.
And this gatekeeper function is absolutely critical. I mean, without it, you just have motor chaos. You'd have multiple, conflicting movements all trying to happen at once. The basal ganglia makes sure that only one purposeful action gets through that gate.
So how does this gatekeeper actually work? Well, it's kind of like a traffic light system. It has a go pathway that gets a motor plan and gives it the green light. At the exact same time, the no-go pathway is like a big red light, actively stopping all those other competing movements from happening. And then there's a third critical piece, scaling. It adjusts the force. It's what makes sure you don't use the force of a hammer to pick up a delicate egg.
Okay, so the basal ganglia has selected the right action and dialed in the right amount of force. But that's only half the battle. Now that approved plan gets sent over to our second manager, the cerebellum. Its job is all about quality control. It's focused on how well the movement is actually carried out.
All right, so if the basal ganglia is about selecting the what and grading the force, the cerebellum is all about the timing and precision. It takes that chosen motor plan and refines it, making sure it's not just the right move, but a smooth, coordinated, and accurate one.
The best way to think about the cerebellum is as the ultimate comparator. Imagine a set of scales. On one side, you have the intended movement, what you want to happen. And on the other side, you have the actual feedback from your body, what is happening. The cerebellum's job is to constantly compare the two and make sure they stay perfectly balanced.
So its to-do list is pretty intense. It's constantly predicting the exact timing for every single muscle to fire. As you're moving, it's comparing your intention with what's actually happening and instantly correcting any tiny errors. And this is how you learn things, how you get muscle memory for stuff like riding a bike or playing an instrument. The cerebellum stores those perfected motor programs for you.
So we have our selector and we have our predictor. But the real magic is that they don't work in isolation. They're locked in a constant, high-speed conversation, a feedback loop that makes all of our fluid movement possible.
It all kicks off with an intention, a goal in your cortex. Like, I want to pick up that cup. That initial idea is sent to the basal ganglia. And it does its job. It selects the right motor program, decides how much force you're going to need, and shuts down all the other possibilities.
Next, that selected plan is sent over to the cerebellum for refinement. This is where a simple command like move arm gets its artistry.
The cerebellum predicts the exact timing and the sequence of all the different muscle contractions you'll need to make the action smooth and coordinated, not jerky and robotic.
Okay, so now the plan is selected, the force is scaled, and the timing is all mapped out. The motor cortex sends that final, beautiful command down to the muscles. But it is not over. The second you start to move, a flood of sensory data, what your eyes are seeing, how your muscles are stretching, starts flowing right back up to the brain.
And this right here is the magic moment. The cerebellum takes that real-world feedback and compares it to the original plan. Is the cup a little bit further away than you thought? The cerebellum instantly sends a corrective signal to adjust your reach, mid-motion, without you even thinking about it. This is why force and timing have to be handled by different systems. The basal ganglia makes the initial call on force, but it's the cerebellum that's constantly tweaking the timing and precision based on what's happening in the real world.
Honestly, the best way to really understand the very different jobs these two managers have is to see what happens when one of them can't do its job properly. And the results are, well, they're dramatically different.
Just look at this comparison. It tells the whole story. When the basal ganglia or selector is damaged, like in Parkinsonism, the core problem is with selection and scaling. You get either way too little movement or in other conditions, way too much. But when the cerebellum, our predictor, is damaged, you get something called ataxia. The selection is fine, but the execution of the move is all wrong. It's inaccurate, jerky, and poorly timed.
So, if we boil it all down to one simple takeaway, it's this. A basal ganglia problem affects what or how much you move. Too much or too little is getting through that gate. A cerebellum problem affects how well you move. The movement gets through the gate, but it's clumsy and uncoordinated. So the next time you effortlessly pick up that cup, just take a second to remember the silent, lightning-fast work of your brain's movement managers. They operate just beneath the surface of your awareness, which really raises a fascinating question. When you decide to do something, where does your conscious choice actually end, and where does the brilliant, automatic work of these systems begin?